Hi everybody, Dr. Pingle here. I wanted to do a quick lesson on how to imagine non-topographic surfaces as elevations within ArcGIS. Most of the time when we symbolize things, we're using oftentimes color these days, sometimes texture, sometimes point symbols, but what we can do is imagine that we're symbolizing elevations. And so what we're going to need to do this part of the exercise is work with raster data. So we're going to be working with a data set that's put out by NASA's Socioeconomic Data and Applications Center, or CDAC, and this particular data set is called the Gridded Population of the World data set. There are a few versions of this. So this is the Gridded Population of the World dataset version 4, so they've been through several iterations. And I would encourage you to just take a look around on this web page and see what kind of data layers exist. I've downloaded this one, so this is the gridded, this is the population count, and it comes in a couple of different years. I think the one that I've brought up here in ARC is 2020. This is going to take a second to redraw. What we're looking at here, I'll pause the video while it redraws. So what we're looking at here, now that it's rendered, is a rasterized version of population all over the world. So the nice thing about this is that we're not looking at polygons, where edges and different sizes can really make things visually cluttered. Everything's been evened out so that we've got a pixel-based view of population instead of a polygon-based view. Now what we can see from the color scheme is anywhere that's kind of this bright yellow or green has high population value. Anything that's kind of darker blue has a lower population value, and then there's a few places with no data, places where just nobody lives according to the record. And you can highlight some of these spots, so you can see a big swath of the Sahara there, which may just be a rendering thing. You can see the Tibetan Plateau to the northeast of India with no one there. But you can also see the high spots. So you can see the Indo-Gangetic Plain just south of the Himalayan mountains of India. It's kind of bright stripe of yellow, indicating a lot of population in northern India and Bangladesh and Pakistan. You can see big highlights in China and so on. What I've done is trimmed some of that out. So that data set is rather large, and so what I've done is created a version of this just clipped out to the Northeast United States. And we could apply maybe a bit of a better color scheme for this to get a better look at it. So we could use something like, I'm not a huge fan of that one, but that's fine for now. We'll set this to standard deviations to kind of bring out some detail. And so what you're seeing here is a representation, again, of population in the Northeast United States. You can see New York. We can see a lot of sort of major cities in the Northeast, Boston. And you can kind of toggle that on and off to see what's what. There's Pittsburgh, Buffalo, Rochester, and so on. So this is a raster of population. Now, how can we view this as if it were terrain? This is kind of a popular visualization technique. We could certainly symbolize it this way and make a map, and that would be fine. But what if we wanted to look at this as something like a hill shader, look at it in 3D in ArcScene? Well, we can do a hill shade calculation pretty easily. So we can just run the tool as if we're running it on a real terrain layer. We're going to use the same azimuth, the same altitude. We could model shadows if we wanted to. The trick, though, is going to be setting the z factor correctly, because if you think about it, the vertical dimension here is really not related to the horizontal dimension. The vertical dimension is a count, and in fact, I used a 3x3 window to calculate the a neighborhood average with focal statistics. In other words, smooth this data out a little bit to make it look a little bit nicer. But the vertical dimension here, the population count, is not really related to the horizontal dimension. So we can imagine that the z factor is really not going to work on this. We're going to run this with a z factor of 1, treating them as if they were the same, but what you're going to see here is that this is rather craggy in appearance. So instead of running this with a z factor of 1, let's run this with something smaller. And you would have to experiment a little bit here. We could try running it with 0.01. Generally, if you're overemphasizing elevation, you're going to want to decrease the Z factor. If you want to increase the resolution or contrast, you're going to increase the Z factor. That still doesn't look great to me. We could try 1,000th. Starting to look a little bit better. Okay, so we really start to see these sort of what turn out to be sort of planes of population, places where there really aren't a lot of people. I think that's still just a little bit too craggy for my eye. So we're going to drive this Z factor down again. All right, that's starting to look a little bit better. So the dots that you're seeing here probably represent particular places. So again, if we turn this layer on and off, we'll turn this one off as well. You're starting to see these sort of mountainous areas by Buffalo, by Rochester, by Pittsburgh, and certainly kind of one big mountain running through the area between Philadelphia and New York, and a lot of sort of mountainous features by population. And those mountains are mountains of people, at least from this perspective. I'm going to export this, and well, actually, hang on. We'll not do that first. I think this is the one that I wanted to export. So we'll leave all of these settings the same. One thing to take a note of is that we're dealing with a elevation source that's not particularly high resolution. So this whole area has 327 columns and 205 rows. So it's not, the resolution is not fantastic. And so we could do things like resample that if we wanted to, but we'll leave it alone for now. What I'm going to do is just export this section as gridded population of the world clip.tiff. You'll have access to that when you are working on your notebook. So what I want to do is create a new view of this. So we're going to go to Map, or rather Insert. We're going to insert a new local scene. And for a ground layer, I'm going to bring in that elevation source that I was just working with. So we're going to go back into our temp. We're going to bring in this gridded population of the world. And so now that's existing as one of our ground surface. I'm also going to bring it in as a data layer. So down here, we're treating it as if it were a ground surface. Up here, we're going to treat it as if it's data to be visualized. Okay, so here's the data as we had it, and we could change the symbology to something more familiar here. We could, in fact, visualize this as if it were elevation, right? So in this case, we've got the sort of, again, mountain of New York. We have this. We could change the percent value, again, to standard deviation to bring out some detail. And so this is, again, one way to visualize this as a terrain. The value of bringing this into ArcScene, though, is that we can explicitly sort of treat this as a surface. So if we tilt this, we can really start to see these peaks. So the New York peak is much higher than anything around it. You can see the area around Boston is much smaller in comparison. And so, you know, the question here is, what does this visualization teach you? What do you learn here that you didn't maybe see before? And I think one of the advantages that you see is that you're really getting direct metric comparisons of the height of these. We could change around with the visualization scheme, but the reality is that the colors don't necessarily make people, they're not able to make those metric judgments in the same way that they could make them ordinarily. And so this is kind of a nice way of really kind of communicating that. Now, It's a lot more effective when it's interactive and you can move this around. And so in a future lesson, we'll talk about how you can render this out to sort of make it move, because you do lose some of the detail if you're not allowed to move this around. But this is a fairly effective way of visualizing non-elevation data as if it were elevations. And the same thing is going to apply in a lot of other contexts. So I hope that you'll think about this and experiment a little bit. I think you'll find it very interesting. Thanks.